Hello everyone, it's Mr. Wolf here, and in this video I'm just going to be introducing our day on Monday, January 10th. And what I actually want to do is I want to do a little bit of a throwback to the formative we did, what was it, I think it was on Thursday, where we were testing the question, how does the size of a cell affect the rate of diffusion of glucose into that cell? So in other words, how does the size of a cell affect diffusion? And if we look back at our key, we had kept everything the same, except we had a small cell here and a big cell here. All right. And then the question is, well, does the size of the cell affect how much diffusion, how much glucose is going to go inside the cell? So what we're going to see is the actual results of that experiment. This experiment's a little bit different, but it's the exact same question, exact same type of setup. But instead of having our dialysis tube bagging, we have almost like this jello-like substance. It's called agar. And we have, actually, this is hydrochloric acid, which is very acidic, which is why we're not doing it in class. It's kind of dangerous. So anyways, you take this this pink dye, and when it reacts with hydrochloric acid, it actually turns clear. So we can see how much of the hydrochloric acid has actually diffused inside the cell. So same amount of substance in this case. It's the acid that's diffusing in instead of the glucose. And instead of our dialysis tubing, we have this kind of jello-like substance, this agar. All right, I'm going to fast forward a little bit. Ooh, this is a great stopping point. So I know it's a little bit blurry, but we could see at the end of the experiment, let's say this looks like they maybe did it after about 5 minutes or so. See this clear line? That's the amount of hydrochloric acid that's diffused in, and the pink is where that hydrochloric acid has not diffused in yet. So that's the small cell, all right? Here they actually have a medium-sized cell. And so notice, all right, here's the distance again that it diffused in. It looks about the same distance as the small one, but notice this really big pink area where the substance hasn't diffused in yet. Right? Same thing with our big cell. It looks like it's the same amount of distance in terms of what's diffused in, but there's a huge pink area of glucose that hasn't diffused in yet. All right, so if we just go back to that original big cell, there's a lot more of this clear area relative. All right, compared to how much like pink we have here, especially when we compare it to, and this is at the end where it's almost all pink right here, compared to when we have this big cell, right? Yeah, some diffused, but a ton of pink, all right, compared to the amount of clear that we see. All right, so if we had to answer our question, does the size of a cell affect diffusion? Yes, and the smaller you are, the more diffusion that's going to take place. The bigger you are, the less diffusion that's going to take place. All right, so the question is, well, why is this? It's a really, really important concept in biology that we've actually already kind of touched on when we got to the lungs last week. It's called surface area to volume ratio. All right, I'm going to get rid of that right here. All right, so what do I mean by that? Well, here we have these different sized objects. Even though they're cubes, you can think about them as like a round spherical cell or the dialysis tubing bag. All right, surface area is the amount of area on the outside, right? So if we were to add up the cell, a 2 by 2 by 2 cell, we have a surface area of 24. All right. And then if we were to take the volume, all right, we would do 2 times 2, so that's one side, and then multiplied by the other 2, that would be 8. All right. And then the ratio is just the fraction, right? 24 divided by 8 is 3. All right. So that's telling me that I have a decent amount of surface area compared to how much volume there is in the cell. Now let's go up to D. There's a lot of surface area compared to this other one, right? But look how much volume there is. 512 centimeters cubed, all right? So if I were to take the fraction of this, all right, 384 divided by 512, it's actually less than 1. It's 0.75 is my fraction, 3/4. So what I want to do actually is I want to compare these fractions. Even though this one has more surface area in terms of the number, the ratio is actually more for the smaller cell, right? In other words, there's way more outsides, way more surface area compared to insides, volume of the cell, right? And in the big cell, there's a lot less outsides compared to the amount of insides, right? And this affected diffusion because there was so much more insides, so much more volume. There just wasn't enough diffusion to go into all of the cell, where diffusion was able to happen really efficiently with the small cell. So this is going to apply to lungs. Remember when we talked about alveoli, your lungs are not just these big chambers. Instead, they're formed of these little alveoli, kind of like these cubes. Imagine how much more faster diffusion, exchange of oxygen and CO2 is happening. And you're going to see a similar thing when it comes to how your intestines absorb food. So your next task is to watch this video right here. There's going to be a link on the website for it. Thanks for watching, everyone.